This lesson will apply to the concept of density, and we'll be looking at density from a conceptual standpoint, meaning what does it mean at the particle level, and then also we'll be doing the math associated with it. So here are your key concepts and goals for this lesson. I'm going to ask you to describe the density of a substance in terms of the relative closeness of particles. And we'll go into what that means, and what I would also like you to be able to do is compare the densities of two substances, not based on the numbers that you're given necessarily, but based on just describing mass and volume ratios. The second goal for today in this lesson is to calculate the density of an object from experimental data, and that's also going to be using that entire density formula, which we will be looking at. So, density. As a definition, density is the ratio of the mass of an object to its volume. And mass is a term for matter, how much matter there is in a given object, and the volume is how much space that particular object occupies. So what density does is it measures, in a way, how closely packed together the particles are. You're looking at mass and then how much space does that mass occupy. So here's one graphic that can show you maybe two different densities and two different objects. So you got some object here with compared to another. Notice that their volumes are about the same. Those boxes, those outlined boxes, are about the same size. But you can see that there's more mass in the object on the left than there is, say, on the one on the right. So how you would compare the densities of these two is that you would say object A, or the one on the left, is more dense than object B. And the reason for that is there's more mass in the same amount of volume. So again, it's that ratio of mass to volume. You're comparing the two. So if you're to say that something is more dense, it has more stuff in less space. And I'm using the words stuff and space that's like mass and volume. So there's more mass in less volume. And if something is less dense, it has less stuff or less mass in more space. So it's going to be maybe a bigger object but with less mass. It's going to feel lighter. So in this case, there is just more stuff, there's more matter in the one on the left. And so that's what makes it more dense. Looking at density now, another detail at least of density is that a density depends only on the composition of the substance. And so the composition really is the atomic structure. So we're actually looking down to the atomic level or the molecular level for density. It doesn't matter how big the object is. So if you have a small piece of copper or a large piece of copper, the fact that it's copper means that it has the same density. So the size does not matter. Looking at the atomic level here are some copper nuclei. You can see they're spaced pretty evenly apart, and you have, because of that, it doesn't matter, we're looking at, say, 9 nuclei right now, but if you have 9 nuclei or if you have a huge sample, the particles, the atomic nuclei, are still going to be spaced out at this distance. So in this amount of matter, in a certain amount of volume, okay, it's going to be the same. It doesn't matter if it's a small sample or a large sample. The fact that it's copper means it has the same density. Now if it's a different substance, these nuclei here, they're going to be maybe a little bit farther apart, so they're going to have a different density. Different substances, of course, have different densities, but if it's the same substance, same density, regardless of size. And so, looking at a density calculation, here's our formula. Okay, it's a ratio, remember, so density equals mass divided by volume. Here are some pretty common units that we'll see for density. You have grams per cubic centimeter, so grams is a unit of mass, and cubic centimeters, or centimeters cubed, that's a unit of volume. Grams per milliliter. Okay, this is a unit of volume for liquids and solids, or sorry, liquids and gases usually. You might also see bigger units like kilograms per cubic meter or kilograms per liter. Now something to note 1 milliliter equals 1 cubic centimeter. So this is a unit of volume for solids usually, like length times width times height, that's a cubic centimeter. Milliliters is liquids and gases, but their magnitude is about the same. So these can be like converted between the two, and we'll look at conversions a little bit later, but they can be used somewhat interchangeably, which is very useful. So let's get to some practice here. Here's this is actually a conceptual problem first. Substance A has a mass of 12 grams and a volume of 30 milliliters. Substance B has a mass of 12 grams and a volume of 60 milliliters. And the question is, which has the greater density? Now you could do this as a calculation, but I want you to try and answer this without calculating. So think for a minute, and you pause the video if you need to. Which of these two substances would have a greater density? And to answer this question, we need to look at simply a couple of schematics. Here would be substance A. And each of these little nuclei here, each of these little dots maybe represents a gram. So you got 1, 2, 3, 4, and then you got 12 there. And you got a volume of say 30 milliliters. We'll just say that's 30 milliliters. And let's look at this. Same mass, right? You still got 12 grams, but they're spaced out. So which one has a greater density? I think it's pretty clear this one does. Substance A has a greater density. Now if you were to do the math, it'd be grams divided by milliliters. 12 divided by 30 would be 0.4, and 12 divided by 60 would be 0.2. So 0.4 is greater than 0.2. So this is more dense. You can look at it conceptually. It's the same amount of stuff in less space. Or you could look at it from the perspective of a calculation. 0.4 is greater than 0.2. So now we'll actually get into some math and actually do this as a sample calculation. So what I'm asking you to do here is calculate the density of a substance that has a mass of 10 grams and occupies a volume of 15 cubic centimeters. There's a problem-solving method in chemistry that I really am a proponent of, which is what I call the holding tank method. And that's where you put all of the variables for a given formula over here. It doesn't matter left or right side, but you just put them off to the side. Then you read the problem, list what is given and what you're asked to calculate, or what's the unknown, and then you do your work over on the side. So this is kind of like getting yourself organized. It's an extra step, but it's usually worth it. So in this case, you're asked to, calculate the density. The mass is 10 grams, and the volume is 15 cubic centimeters. So we're just dissecting the problem, really. Here's our formula. And so now what you're doing is you're just plugging in your information here, over here into your formula. So density is 10 grams divided by 15 cubic centimeters. And so you end up with 0.67 grams per cubic centimeter. And I want you to notice a couple of things here. Each of these digits has two significant figures, and so we have 2 in our answer. Your calculator, if you do this, it would spit out 0.666666667, right? 2/3. But those are not all significant figures. We get 2 significant figures because we have 2 here and 2 here. Also notice the units. Grams divided by cubic centimeters in the problem means your answer, grams divided by cubic centimeters. The units get subjected to the same math as the numbers. All right, let's look at another one. Calculate the density of a substance with a mass of 5.0 kilograms, and a volume of 3.00 meters cubed. So set up the holding tank, and what I would like you to do is give this problem a shot on your own, pause the video, take care of it, get to a final answer, use proper units, proper significant figures, and then restart the video to see the logic of the answer. So go ahead and pause the video now. Okay, so let's go through this. Density is unknown once again. The mass is given, 5.0 kilograms. Volume is given, 3.00 meters cubed. That's our holding tank. Setting up the formula, density equals mass divided by volume. Plug in what you know. and then we get to our answer. And again, your units need to be dealt with the same math, so kilograms divided by meters cubed, and then also looking at significant figures. This is 2 significant figures, this being the digit that's a guess. This is 3 significant figures. This is the digit that's the guess. So your answer should have 2 significant figures. 1.7 kilograms per meter cubed. And we're going to do one last practice problem that's maybe a little bit more challenging. A substance has a density of 1.5 grams per milliliter. So you're given density in this case. The algebra is what we're going to be working on here. And a volume of 40 milliliters. What is the mass of this substance? So here's your holding tank. Go ahead and set up your holding tank. Give this problem a shot. Pause the video, and we'll be going through it in just a moment. So, you're given the density, 1.5 grams per milliliter. You're given the volume, 40 milliliters. You're asked to find mass in units of grams. Set up the formula. Now, this formula, as it is, it's not going to get us what we need. We're looking for mass, and so you need to isolate that and get it by itself. So you multiply both sides by volume, and I'm not showing that particular step, but if you multiply this side by volume, it'll cancel out this V. And then this side multiplied by volume, you end up with this. Volume times density equals mass. Now you can plug in your numbers, and you end up with a mass of 60 grams. Notice the units here, milliliters times grams per milliliter. You've got a milliliters in the numerator and a milliliters in the denominator. Those actually get canceled out, so you're left with grams. And then you got 40 times 1.5 is 60. 2 sig figs, 2 sig figs, so you have 2 in your answer. So we're at our recap now. That's the end of our density lesson. We looked at density from a particle standpoint and particle arrangement. We also looked at comparing the densities of objects based on their measurements and what you're given, mass to volume ratios. And then we also gave a shot at calculations. Some of the calculations might be a little bit more challenging than these that we did here, but this was just to get a basic introduction to that particular formula and how we solve those problems.